presentation real quick. It's not there. So go to the points, lines, and planes stuff. This is actually not in your pages. There's one quick thing where they mention intersections. If you can find that, like we're going to talk about how, and I think we talked about it a little bit. We're going to talk about how lines intersect with lines and lines intersect with planes, and planes intersect with planes. So, was that the door? Yeah. All right. So can somebody grab that real quick? Well, I'll jump on. Bricklin started, then he's. Yeah, so I'm going to show this to you. It's not even anything I can really record. It's not even anything I can really record. So the people, if you're watching the recording, this is something I just did in front of the class with the little cardboard cutout stuff that I had. Why is that not open? There we go. Oh, I'm also, since today is oh, by the way, make sure you're in your second period class. Even block day, so everybody should be in my second period. Oh, there you go again. This is why this is going to be a pain in the butt. Talking about the fact that we have this new tardy system. I mean, this is driving me crazy. Open. Thank you. Forward. That one. And there, 5. God, my computer's really projected. So we're gonna finish up points, lines, and planes. Then we're actually doing 2 lessons today. As we were behind, this is kind of the one that I use to catch up. The first lesson I think is super, well, the geometry part of it is super easy. And then if you're okay with algebra, the whole thing is pretty easy. If you're not okay with algebra and you struggled with algebra, then the math part of it will be a little tricky for those people. So we are probably gonna, now that it took me a little while, so we're probably gonna skip over the bell work. I just want to show it on the screen. That would have been the bell work. It was nothing that crazy anyway. Review of the points, lines, and planes stuff. So really quickly, so you will have to take all these notes. They're not in your book. If you found the little section that says intersection, I think it's either off to the side of the page or it's in one of the little like boxes that are set off, like maybe did you find it? Yeah, like a yellow box at the top. What page is that? What is it? 9. So top of page 9, the little yellow box, it just briefly mentions intersections. That's about all they do. But I feel like this is going to be something they ask you on midterm EOC. I will ask you about it for sure, because there are questions about it in the problems, but for some reason they don't really tell you how to do it. But I'm going to show you. I already did. Where's my line? I'm not playing. All right. So if I have a plane, well, first of all, let's talk about 2 lines. So I have 2 lines. First question I have is, will the lines always intersect? Let's think about that. We're going to do raising hands. I have 2 lines. So here's my line. Here's my line. Will they always intersect? Raise your hand if you think yes, they will always intersect. Anybody can raise their hand. There's 1. There's 1. That put the other one. Yeah. If we're in 3-dimensional space, they definitely won't. Like, so 3-dimensional means they're not plastered on some kind of a coordinate plane. We're not just putting one here and one here. If they're in 2 dimensions, then they will almost always intersect. When's the only time they won't intersect? If they're both on this same plane. Yeah, if they're parallel, that's the only time. Any other angle, like even if you see them like this, well, remember, lines go on forever, so eventually they're gonna intersect. On 2 dimensions, the only time they don't is when they're parallel. 3 dimensions, though, like this one could be going that way, and this one could be way below it and going that way. If they keep going, they'll never intersect. Like there's a bunch of places they won't intersect. That. Sometimes they will intersect. If they happen to be in the same plane, and if they happen to cross, they will intersect. Like before I even show you what geometrical shape, what is the intersection of 2 lines? What do they form, or what's that thing called? Way easier than you thought. It's one of the things we want. Yeah, it's point. So remember, this is a bunch of points. A line is a bunch of points. They go on forever. They're following a pattern. The slope is actually the pattern they're following. And they're going over 1 up 2, or over 1 up a half, or whatever the pattern is. And they're just going to keep doing that. These points are following a different pattern. If they eventually intersect, all that's happening is they're sharing a point. There's one point that's on both of those lines when they intersect. So if they share that point, and just that one point is all they share, then their intersection is a point where they touch is that point. So that's the intersection of 2 lines. So the answer is either they never intersect, or if they intersect at a point. Can they ever intersect at anything other than a point? Yes.
Through a plane.
What do you mean through a plane?
If they intersect through a plane.
So if well, no, I'm saying just these 2 lines, I'm not talking about them intersecting with another, like these 2.
They only intersect ever once.
So you're saying they'd only intersect, like if they keep going, they only intersect once. Is that right?
Yeah, they're not gonna see them. Let's put another line.
What?
Let's put another line.
Yeah.
They intersect, it usually only makes 1 point, because it would be going separate ways after that. On both sides.
So again, and this is a little bit of a philosophical question. I have that line, right? And we'll say now that's a line that I've already graphed. There's an equation for that line. I have another equation, right? Let's say I graph that second equation, different equation, like it's got different numbers, maybe even different variables, different equation. And when I graph it, it lands right on that line. They're intersecting, they're touching. So they theoretically, and again, now the argument is, well, really, in order to be on top of each other, it's really the same equation. The equations will look different when you look at them, but there would be a way to like simplify one of them down. But if it's a different variable, you can't really simplify it because now you got different variables. So just understand, you did this before. Do you remember doing in algebra, whether you solved out or whether you graphed? There were sometimes options or answers that were no solution, or all real numbers was a solution. That's all real number solution. When one line lands on top of the other line, that means all real numbers. So technically they're intersecting at every point. They're the same line.
Isn't all real numbers just another meaning for infinite solutions?
Yeah, same thing. Yeah. We normally don't say, I guess I've seen infinite solutions. I more often see all real numbers. It depends on how you write your answer. Like if you're putting it in a subset, you say all the set of answers is all real numbers. If you're just writing it in words like no solution, then you would say infinite solutions. The book, I think this particular book, I think says real numbers more often. All right, so now let's talk about planes and lines. We sort of did this one. So again, we have this plane, we have this line. Will they always intersect?
Yes, well, yeah.
Really?
Yeah, planes are infinite on a flat surface, so eventually, no matter how far the line.
Really? Does everybody agree with that? He's pretty confident. He seems to know what he's talking about.
You said plane, right?
Yeah.
Yeah.
What about that?
And they're parallel.
So will they intersect?
No.
So they won't intersect.
You had it up and down.
Oh, I just meant a line and a plane. I'm sorry. The way I had it, yes. The way I had it, yes. These would, even though they're out. I'm sorry. I didn't mean to say this is the way they are. Yes, those would always intersect. What would the intersection be? So now we're back to this. So this is the way they are. What would the intersection be? Would it form? This is a row of points or a pattern of points. I got that. I got something. Come on in. Gonna be a pain. How many people were still in line up there?
A lot.
Again, I told you, did I tell you guys how long they were gonna wait and then supposedly close it initially?
Yeah.
5 minutes,
Like, yeah.
and now we're at about 15 minutes. And still a bunch of people up there, it sounds like, so. This system is gonna change. I have a feeling to where we just go back to marketing retarded pretty fast, because this is not. Especially in the first class of the day, just too many people get like. So we're doing intersections, so pull those pages out that we had from last. This is not really in those pages, so we're just adding the notes into them. They don't really talk much about this. So again, what will the intersection be? Again, intersection is where they touch. What is formed where they touch? Just a point again, yeah, because again, this is a whole bunch of points. This is one line of points. So when this cuts through, if this is only like a line of points, there's only one point they're going to touch it. So that's what I kind of did that before you push that through. They are sharing that point D. It's D because that's just what I named it on the point. So they're sharing that one point. So their intersection in this particular case is a point. And then in this case, we said it's what? They don't intersect at all. Are those the only two options? Why not?
Fine. This math I've been asking.
Not always. Not always. What did we do with two lines?
Overlap.
Yeah, I could be that line. I could be what's that word? Oh, coplanar. If the line is coplanar, then there's infinite solutions. They're all real. They hit everywhere that line is. It's on that plane. It's part of that plane. So with a line and a plane, you got all three options. It could be any. With two lines, it's either they don't intersect or they intersect in a point. With a plane and a line, could be all three. They don't intersect. They intersect in one point, or they intersect infinite points. And then our last one you got to know about is two planes, and then we'll do three planes. So if I have two planes, will they always intersect? Why not?
Parallel.
Again, the parallel thing is your go-to for not intersecting with two lines. Actually, it could be in a lot of different ways they wouldn't intersect. But if you're talking about a plane, because it basically is going to go out in every direction, it'd have to be parallel with something to not intersect. Now, if it does intersect with another plane, what's it going to form? So I got this plane like that, and I got this plane like that. So what is that thing that it forms?
One point.
Not one point. You said multiple solutions. So what are those multiple points going to look like?
Place where they intersect, just a bunch of points.
That way. It's a line. It is a line. It's exactly what it is. They will never intersect in one point. Never. Not a possibility, because this is a whole bunch of points. It's going to wind up hitting a whole bunch of points. And those points will be in a row. Yeah, I was going to say, I thought I had the way to show you that better. There we go. So this plane is cutting through that other plane. Again, I could change the angle. Doesn't matter. This is more of a right angle. Doesn't matter what the angle is. Never going to be anything except for a line, unless what?
That center point right there is.
So where they cut through each other, basically, That's gonna be the line. What's the only way that it can be, so it'll never be a point. If they're parallel, they won't intersect at all. Most of the time, it'll be a line, because they're most of the time, no matter what the angles are, unless they're parallel, when they intersect, they'll make a line. What's the only other option for them intersecting point? Yeah, just like the two lines. Just like the two lines could be on top of each other, we could say one plane. We could say one plane happens to be right on top of the other, and again, then go back to infinite solutions. So a lot of that is just visual. Holy cow. We could fill a bunch of people up there. So funny. A lot of different scenarios between two lines, line of plane, two planes. Sometimes that's just a visual thing. I show it to you just to try to help you, but there's really not a lot of problems. I don't know if there's any problems in there, but this, I do believe there was something like this on the district test, maybe even the EOC.
The problem we did yesterday, where E was the triangle above, could that be considered?
Yes, they could have asked you questions, but they didn't. I don't think there were any questions about
It
intersection.
was just referred to the figure name 3.7.
Well, I'll look back through the questions at some point, and if there are some, I'll review it before the quiz. Because I think I do have some intersection questions on my quiz, just because I'm pretty sure I remember it was on the district. Oh, one last thing. What if there are three planes? So I have these two planes. This plane is gonna rip me. What if I have these two planes? They're intersecting. And now I bring in a third plane. And again, remember the plane, it's a smaller size, but remember, it goes in all directions. And it intersects with these. What's gonna form? What's that? What's the intersection of all three gonna be? Always.
So we're just not more dots.
Well, technically it would have more because they're sharing the dots. Remember the number of, just because I could add a line, I like all kind of stuff. They're just sharing that one center line.
If you put slightly over to where it will be over, then look where it will.
Well, no, because
If
again,
it's
it's
parallel.
eventually, I want to know where all three of them touch, not just where this one touches one and then where it touches the other one. I want to know where all three of them touch, which they will eventually all three. I'm going to show you.
Where did that make a second one?
So are you saying a line or a point is what the intersection of three point?
Which is another point.
Well, you can't add a point. They would share a point. 'Cause remember, the points are already there. I can't make another point like that point is there. If you're saying. Anybody else? And I'm just gonna show you this. It's a very visual. So if I take this plane, there's actually two options. I like the other. I can't really make it parallel to both of them because I want them to intersect. Like the question is, if three planes intersect, what is formed? So I'm not gonna make it parallel to one and not touch one of them. I want it to intersect with both of them. I can change the angle of this and that determines the solution. If the angle is like this, or really any version of that, so really all you're imagining out of this, there's just a line here, because that's where these two. So all this is a line, right? It's formed by these two planes touching, but we're just imagining the center line. So imagine that being a pencil going down the middle of those two. So if I take this and I put it at any angle like this, it's gonna just hit that at one point, right? So the intersection of those three would be one point. But if I take it and I turn it and I match it up exactly with that pencil and it goes through the pencil, that then would mean that these would intersect in a line. So the option for three planes, they're either going to intersect in a point or in a line. So you have those two options. And again, depending on what the question is, you'd either have to explain or figure out which one it is, or that specific scenario, I think, is what is in the book. It asks me somewhere, I believe, about three planes. So that's why I definitely show you that one. God, that took so much more time. But, well, I'll take that, please. Were there still a bunch of people up there? Oh, yeah. I didn't even look to see how many of these you guys have. So it looks like everybody's fine. Nobody's, although I think they reset it today. Did they say anything about that? Like today it started over, so everybody will have one on here, I guess, today. Yeah.
They take what, class categories today? Yeah, it's 2, 4, 5. Oh,
Yeah, today.
So when I had that, I went to the first class and then they told me I had to go.
Yeah, today's second period, yes. That all your even classes, except you still go to fifth. You go to fifth every day. So today is an even day, although they actually don't call it even. I think they call it like red or blue or something, which I've never really understood. All right, so now we're gonna get into line segments. This first lesson, before I assign a few problems, is super fast. Going through the whole thing, the concept is easy. I think. We'll see. We'll find out. And then if we need to back up, we'll back up. The concept is super easy for every single problem. I don't care how tough the math gets. It is the same exact geometry concept. And yeah, I think it's easy. This is one of the easier lessons, I feel like. Kids did much better on this quiz than they did on the points, lines, and planes, but not because that first one was hard. I told you, you've got to be detail oriented on that first one. So with that in mind, what's that? What? Line segment. Thank you. Because are there arrows on the end of it? No. It is not a line. It is a line segment. Oh. Now the people on the recording can actually see what I'm doing. So that is a line segment. How do we name a line segment?
By 2 points.
And what's the most important thing? Because we do that for a line also. What's the most important thing? Yeah, the symbol over it. I don't think saying line, I mean, if you say it, saying line segment AB, you can obviously say that. I don't think you can write it though. Like we can write line AB if it's a line instead of line segment. We can't write in front of that line segment AB. I mean, I guess you could, but really the real way to do it is that the only way to name it? No. We could flip them. What if I do this? I'll just write it in. And is that still referring to the same line segment if I do that? No. No, it's not. Good. So here's the difference between, just quickly, we did this already once, I'm just reviewing it. The reason that I have to be more detailed with line segments, if it was a line, I already did AB. Actually, here, let's flip those. CB. All of those, well, not all of them, I'll put them in groups. That group, those refer to different things in the image. Because I have multiple line segments. How many line segments are there?
2, 3.
3. Your hint was you have 3. There are 3 line segments. If you ever have a line with the arrows, there's only one line. Actually, we can still make this into a line. And we can talk about the whole line itself, or we can talk about the line segments within the line that are part of the line. So that's why when you do that first quiz and you are naming lines and planes and stuff, you've got to be specific because all of this stuff has a different meaning when you start adding line segments in multiple points and stuff. This particular group talks about the long line segment. This particular group talks about this smaller line segment. This particular group talks about this smaller lines. So again, just be careful. It's not super difficult, but the first quiz, sometimes kids aren't used to being very detailed on their answers. So, all right, now here's today's lesson. I did not. I mean, I obviously meant to. I didn't know it was going to be racing. All right, good. slower, but it's probably not. Now we're back to when we started. All right. So here is the only concept you need for this. Again, to me, this is just completely obvious. The only concept that do I have? Oh, man. I meant to bring in, I told myself last year to bring something in for this. Like a physical thing. I guess I'm gonna sacrifice one of my cool awesome things. Luckily, I have quite a few. All right, I got a line segment here. So now this is a line segment. It has endpoints. So it doesn't go on forever. It's a line segment. That line segment, I'm calling you for this right now. This line segment has a length of 10. Doesn't matter if it's inches, centimeters, it's 10 units, whatever that unit is. 10. Right? 10. I love these pencils. Oh, they're rubber. What happened? What do I have?
That's so.
Two line segments. Now I have two line segments, right? Broken into a little bit smaller one, a little bit bigger one. Still the original line segment, though. I just broke it into two. So what's true about those two line segments? Right there. Because it's two, I'm holding them together, but it's still two. What's true about those two? Yep, based on what I told you about the original line segment. What did I tell you about the original line segment? What's true about those two? Yeah, they still equal 10. I did not change anything from the original line segment, other than I broke it. It's still 10. Right? Anybody struggling with that? Because that's the concept right there. That's it. You understand that I'm just taking an original line segment and making more line segments out of it. That's it. Well, now we'll get into the lesson. So again, that's your physical lesson right there. All I'm doing is I am taking an original line segment. Yeah. I'm taking an original line segment, so that's the original, and I'm going to break it into two smaller line segments by adding a point onto the line segment. So we're going to take a point and we're going to put it there. We'll name it C. So here's now we're getting into the math part of it. I would always start with this. Again, if you are completely getting everything and you got the algebra down, then I won't take off if you don't do this on your quiz. But if you're struggling even a little bit with the algebra and you show me this part, I can say, well, at least they kind of have the geometry concept. And I'm like writing it in words first. That's your concept. Every single problem you do, I don't care how difficult it gets. Every single, like this, how difficult the algebra gets. Every single problem is based on that geometry concept. We just took a larger line segment, put a point on it, so we didn't actually break it into two. It's still the original and it's still intact, but we put a point on it, which now creates two additional line segments. And this is called a property that when we get into proofs, we'll use quite a bit. It's called, actually, and when you get into proofs, it's called something different. It's called like the additive property of line segments or something like that. They call it, I think, it's in your book. The exact, oh shoot, no, it's not. We haven't torn the page yet. We'll tear them out in a minute. It's called like the addition postulate of length or something like that. They don't even refer to line segments. But yet, when you do proofs, they refer to line segments, not length. So the book's not even consistent in itself on that. But that's it. So if I now do something like this, I'm going to start super easy. Don't think this won't even be on the quiz. So don't think this is how it's going to be. What's AB? Yeah, so again, here's the first thing you need to know. When they write numbers in like that, those numbers refer to the smaller segments. So if that's all they did and they just wrote it in like that, those numbers are referring to just the small segments. Sometimes they'll actually do it like this, and I'll do it both ways on the quiz so you can get used to it. Sometimes they'll write it like that, and then the question will be like this. AB equals, and you got to figure it out that way. So there's multiple ways you're going to see it. Our book does it both ways within the same book. But you know, if you then go to the district test, they might do one and not the other. So that's why I like to put both of them in the lessons and the quizzes, just because I have no idea what the district's going to do or the state. But again, same concept. Little plus little is big. Doesn't matter how they're showing you where the information is or what given data they're giving to you. If they do give you a link, now let's do this. So if they do give you or if they do give you the big length, we'll just use the same numbers. That's fine. Here's how they would, and again, they could. You guys had the little plus little here. That's my way. Oh, that's so slow. So the way that they'll typically show the long segment is they'll put like little bracket things. They'll put a number, the 10, and then they'll put arrows showing you that that 10 represents the whole entire line. So when you see that, that means that it's the length from wherever the two lines are. So I mean, and they could do that for just these little ones too. Like it doesn't have to just be for the bigger lines. But you'll see those little brackets and then the arrows and a number in the middle, and that's telling you what's the, I mean, again, I used to take for granted that everybody understood the figures, and I didn't really go over this. So if you're bored out of your mind, don't worry, it gets harder. You're in luck, it gets harder. Let's see, anything else that's really general stuff for before we get into math. All right, so I'm going to do one easy one and then just go straight into one that's more difficult. That question. So if we have a problem, and remember, everything is based on what? What's the concept? You got to remember that I wrote up. Everything is based on that, right? So this is not easy, but it's not super hard. I don't. And we'll say now we'll change the number. And I'll put in, so again, I'm making it easier certainly than some of them will be on the quiz, but we'll say that. I want to know what is AC. Figure it out. If you should all be able to write an equation down. So at the very least, and that everything you do gets you points. So if you can't get to the end of a problem, don't ever leave it. That's the only way. Oh, not the only. It is possible to fail one of my tests by answering everything, but it is really rare. Like if you're giving me some information for every problem, like you're like, well, I have no idea how to actually solve and get a C, but I remember what is it you need to start with? The concept. Come on, somebody. Little plus little is big. I remember little plus little is big. And if you can then create the equation from that, you have no idea how to solve and give me the rest of it, but you can create the equation. Sometimes just creating, like if you could do that for every problem, every equation was good and you didn't even know how to begin the algebra after that, I get you a C sometimes. Because this is geometry, it's not algebra. Part of the standard is that you can solve and figure it out. But I give you a C if you know the geometry standards on the quiz. So go ahead. I want you to tell me what, here, I'll write it in a different way so that this isn't, oh, I did not mean to do that. And things are going so slow. There. While you guys are figuring that out, I gotta fix this real quick. There we go. I didn't work. What? Not working. Again, copy. My computer sucks. Stinks. There. So I'm gonna go pretty fast because again, I don't believe I'd rather you have a lot of practice time and then help the people that are struggling individually. Concept is what? Just repeat it. Again, everything is based on that. And there's actually another lesson where everything is based on that same exact concept when we get to angles. So if you can get this one down, should be in pretty good shape for that one. Little plus little is big. Now we just, when I used to do algebra, I'd tell them to write like when you had to create an equation from a word problem, I would tell them to create something like this with the word problem. And that's basically what we did. We created a kind of like a word equation. Now we just plug in what's, like I theoretically could say little one plus like little one, meaning the first little one, the second little one. Now we just plug in what we know is in the positions for all of those. So what I'm going to start with Brianne on this and now go around. Give me what goes in the first little. 3x. And it doesn't matter which one you put there. I'm not going to mark off if you don't put the 3x. It's the first one. Vanessa, what goes in the second little? 4. And who's next? Oh, Gavin. Say what? 18. Yeah. Remember, we're using no. Now we're creating an equation with it. Sure, equation. No, this is not really slope or anything. That's not. Now it looks like that equation, but I might have had like 4x here instead of 4. So it just happened to be because I made it easy. I might have had here 3x subtract 2, and over here 10x plus 17. So yeah, no, there could be anything in those. There might not even be numbers theoretically, but you wouldn't be able to solve it if that was the case. All right, so now what do we do? And I said I want to know AC. What do we do now? Now you're into algebra. What do I do? Do what? Yeah, we need to solve for x, right? Now we're at the point where we start solving for a variable. So this is a 2-step equation. I made it pretty simple for the first one. The math definitely gets more difficult than this on some of the problems. I subtract, blah, 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 blah. Here, I'm just gonna 3x plus 4 is 18, just to make it. What does solving mean? Everybody just says that it's the same word to define. I'm going to give you my definition of it.
Find what x is in this particular.
I mean, yeah, it does, but how do we do that? That's what I love right there. Solving just means get that variable by itself. So if I want that variable by itself, I got to get rid of that 4 in that group. So if you remember, that's really all solving means, is just to get the variable all by itself. Even if you have multiple variables and variables on both sides, that will, I think, help you remember the algebra behind it, certainly in one like this. You do have to know which one to start with, but I'm hoping we're pretty good in that area. 14. So last step, again, if I want to get x by itself, I got to do opposite math. I'm kind of undoing what's there. So I divide by 3. I'm not going to spend tons of time on algebra in this class. You're supposed to know the algebra. If you struggle with algebra, I'll give you some things that you can do to practice. You'll get quite a bit of practice in class because after the geometry concept, like after you set the equation up, you're going to be doing algebra a lot after that. But the faster you get that down, the better off you're going to be. And I'm just going to leave it as 14 thirds. Yeah, I'm just going to leave it as 14 thirds. 4.6 repeating. Yeah, exactly. And we're going to use calculators today. And I'm going to show you that has anybody ever used the fraction button on the calculators? There's a button on your calculator where you just put that in as a fraction. You don't have to change it to a decimal or anything. You just plug it in as a fraction and then you can put it back in and do the math. You know, that fraction times 3 plus 4. And it'll give you the answer as a fraction or as a decimal if you really know how to use the calculator, which we'll go over using the calculator. That's a big part of doing well on ACT, SAT, PSAT, the district geometry stuff, the state geometry stuff, the EOC. A lot of that's just being able to use a calculator and being able to get through the problems fast enough to where you have plenty of time to work on all the problems. So we'll spend quite a bit of time learning some different functions you might not use on a calculator. So what's the answer? I'm just going to leave it again as that. So is everybody good? Anybody have like any different answers that we need to clarify?
You could turn it into a mixed number.
Boy, I thought you were on top of things for a second.
No,
You could turn it into a mixed number. It doesn't change the value of it. We're all wrong. Every single one of you just missed that problem.
oh yeah.
Why? Why do we all get that wrong? Did we make a math? I'm telling you, you made a math error. We made the wrong equation. We all missed it. That's why I was going, ooh, so what did I ask for? Did I ask for X?
Solve for 18.
I said, what's AC? Is AC X? What's AC?
3.
3 times X, right? We have to do this. That's what AC is. Here's the moral of that story. I'll do that a lot. So if you ever think that I'm wrong, don't hesitate. And sometimes I'll just make mistakes. But I'll make intentional mistakes a lot to try to drive home a point after you solve for a variable. I don't care what lesson we're on. After you solve for a variable, you better go back and read what the question is. I guarantee you probably more than 50% of the time, they didn't ask you for the variable. They asked you for something else in geometry. They want you to figure out what's the length of the segment or what's the measure of the angle or something like that. I don't know. Is that holding anybody else? I haven't, just hang tight because I got to write passes now, but yeah.
That just makes 14.
It does. So the length of that segment is 14. 14 plus 4.
Main thing that was throwing me off is that that's
Oh, actually, that's a great point. If I asked you for AC, we didn't need to do any of that. Because we could have just said, well, if I just want to know the length of that, I know this is 18.
that's 4.
I know that's 4. That's just 14. We didn't need to do any of that.
That's all I did.
Yeah. So yeah, I didn't even think about that when I set it up. I mean, we still went through the process, which is what you needed to see because the problems won't be like that, which is a mistake on my part. Typically, if there are variables in it, there's going to be variables in more than one spot. So like 3x here, and maybe this is going to be 10x plus 2, something like that down there. But again, the little plus little equals big is still the way you set up the equation. All right, so here's what I want you to do. You should be able to do the vast majority of the problems now. I'm skipping over practicing in points, lines, and planes. I'm going to assign you some problems in it while after you get, but I want you to go ahead and start doing line segments. And then once you have that down, go backwards to the points, lines, and planes practice. I've assigned you Excels for both of these, by the way. Set like a few Excels, I Excels. we're not gonna worry about that today in class, because like I said, my quizzes match the book more so than IXL. But if you want to practice IXL on your own, you do, oh, shoot, that's another question. Raise your hand if you do not have a laptop that you can bring in to work, because I'm not letting you use phone. So again, I know they distributed it with, I don't mean today. I'm sorry, I don't mean today. I mean at all. You don't have one at all. Ninth grade? You're not. If you have a one you can bring, because again, you can get to it through the internet. Yeah, you can get to your Clever from any computer. Yeah. So as long as you can bring, I'm not letting you use phones. I did that last year and kid goofed off one day.
I haven't got a laptop yet, so I could bring it.
All right. So again, you don't have to ever bring one. It just means you won't practice IXL. You'll only use the book pages, and there may be times when I have to create some additional stuff because it's not tons of book problems sometimes. So just know it's up to you. If you would rather be able to do that, you can't use your phone. Some teachers let them use phones last year for the beginning part, and then people were just doing other stuff. Then they were going to IXL, just answering something, but they missed 1 out of 20 questions. Just guessing. So if you want to be able to use one, then you can now, unfortunately, we don't have our media center person, so I think that's on hold a little bit for us. But just know, if you want to be able to do the IXL stuff, you gotta have a laptop you can bring.
Go down a hall, and then the only double doors go through there, and then find the door that says computer help. Yeah, that's what I had to do like yesterday.
But can he issue them, or he can't? Because they sent an email out saying that was
The
on
one that
hold.
runs the computers.
All right. No, I know the guy you're talking about, Mr. Cheney. Last name.
Yeah.
So if you want to try to go ahead and get one, I thought it was on hold, but if you want to go into the media center and talk to Mr. Cheney and see, I think the process is you're supposed to go to a website somewhere, but
They
I
said you
don't
can do
mind going to, I mean, again,
yeah.
I'd try to go to him first, and worst case scenario, he tells you gotta go to the website, but because he'd be a lot faster if he can just do it. Oh, so here are your problem. So you're always responsible for examples. Again, I didn't go over any examples. I gave you the short version today because this is my lesson to try to catch up. But example 1 on page 15. So by the way, grab books. The books, you start over there this time, because we've already torn them out once, so we put them all over there. So everybody grab a book over there, and I'll tell you what pages. Today, we're gonna tear quite a few out. So we're gonna tear them out for probably 3 or 4 lessons, except just the one lesson we did. So we'll probably go, yeah, all the way through the end of that module. Holy cow, dude. Oh, did you come in? Did you just get to school? So you came in. Long walk. A walker, apparently.
Or the question, like, double the time maybe.
Yeah, let me go ahead and write your pass. Where's my, okay. So have a seat, and I'll tell you, you're basically tearing out all the way through the end of the module. I'm going to skip some of the pages at the end, but if you just want to tear them all out, there are some good practice problems at the end that I don't make you tear out, but it's not gonna hurt to tear them out. So like from 15 through the last one you have to have is 48. If you want to tear out past there are some good practice problems past there also. But you have to go through 48. That's what I'm going to write on the board. There we go. Well, maybe that one. There we go. CK LAN. And oh, 8, let's say 15th. And we're going with 820, let's say. And bring that back to me because I'm going to use that throughout the day. So, oh wait, I need your phone. Man, I almost forgot that. Oh, so once you get those torn out, I'll just write it up on the board. You guys keep tearing them out. I said you have to go through 48, but then there's an end of the module like review or something that's got some pretty good problems in it for everything. It'll be points, lines, and planes, I think, and I I think that's the end of the module. Yeah, that's the end of the module. So again, every end of module has like if you just kind of want to test yourself to see how you're doing, every module has like a little self-test at the end. I mean, it's not self-test. Some teachers use it. So I don't make you tear it out, but it's not a bad idea. So the other option is through page 56 if you want to include that module. I'm that little self-testing. Sometimes I do pull questions from it. So it's like, why I say it's not a bad idea to tear it out. Boy, that didn't even really get caught up, but we are gonna do another real quick. Oh, your first quiz is gonna be on Monday. Now it's gonna be a little weird. So here's the deal. I'll wait till you clear out because you need to hear this. So let's see. So what problem? Oh, I gotta write up here. Line segments, example 1, 2, and 3. Week 15 through 48. Let's go with red. Hopefully this. Oh, no, I want that. Gotta learn its name, but we gotta do it. There we go. Like I'm writing in black. So, oh, actually, no, I'm not. I'm still writing in blue. This is part of your first quiz. So your first quiz will be the point lines and plane stuff, and it'll be what we just did online. Now I am going to teach you something else before your first quiz, but it will not be on the first quiz. That's why I say it's a little weird. But we have to do that because we're in blocks and I can't give you a whole block to practice because then we get too far behind. I didn't even assign so that's page 15 through 48 you had to have. And now I'll give you the problems. So it's going to sound like a lot of problems, but you'll see the first, 9 are as easy as they can possibly be. Like it'll take you 2 seconds. Oh, you're going to need a calculator also. If you don't have one, you can grab one over there. So I'm going to give you problems. For now, 1 through 23. We're going to add one little piece to it. Probably in like 10 or 15 minutes. Just look up here. For you can see it, so you can just look up there. You forget. Eventually, I'm going to assign also 28 through 33. Yeah, you tear them out. Did we not? Which one not? Maybe didn't you? You don't. What am I? 1 through 23, and then I'm going to do 28 through 30. Oh, I got, and now I'll add to it, and I'll tell you this in a minute, what you're gonna be responsible for. Oh, no, I assigned points line and plane stuff, right? It was up on the thing, yeah. So here, I'm gonna go back to that. If you weren't here. Oh, that's a different, shoot, that's a different. So the problems for line segment, if you didn't hear me, right up here. Right now, that's all you can do. I'm going to give you another quick lesson in a second, and then you'll be able to do these. But you're responsible for all of these on the first quiz. It starts on, if you don't, I didn't write the page up, but if you want to know what page those start on, they start on page 19. So go ahead. Again, if you didn't grab a calculator, looks like most people have, you will need one. I mean, you can try to do the math in your head if you want. I wouldn't need that personally. So line segments, that's the problem for line segments. So page 19, I think I said. So that's your line segments assignment. I'm about to get rid of that. So write that down real quick, what you're supposed to be doing. I'm going to put the name, points, lines, and planes up on the screen so I can write it over there on the board. I'm going to keep recording just because we're going to do another quick lesson in a minute. So, oh, sometimes in the recording there is dead space. Don't stop. Don't cut it off, because a lot of times I leave it going, knowing that I'm going to do another quick lesson in like 5 or 10 minutes, which I am. So if you miss a day, don't stop as soon as I pause or I stop talking. Fast forward. All right, so practice also page 11. Over there in the corner. Oh, this Compton. If you don't know the Compton, she's just gonna help me out here. Was it Tuesday and Thursday for this class, or just Tuesday?
Tuesday, Thursday.
It is Tuesday and Thursday. Let's see. This is problems. 1 through 19, 25 through 31. Oh, and then I forgot the IXLs. There is an IXL for the line segments too. You got plenty to work on right now, but I'll put that up there and probably at the end of the class after I do the next little lesson. Hey, oh, if you have questions, I don't care if you work together. Again, you're my employee. I'm looking for results. If you get better results by working with somebody and you know somebody in here, do that. If you don't want to work with anybody, I'm not going to ever make you form groups and stuff, even though I'm supposed to. So, do you know where they are? Over there, it's labeled pencils. Oh, I think if I told you guys all the supplies are over there, like anything over there is for students, so. It's not for you to like load up on paper. I don't want you taking a whole stack of paper, but for this class, if you need something, should be over there. Highlighters, Post-its, all kind of stuff over there. SVU. I'll put the other IXL up for line segments later. So if you need help from me, once I get done with my stuff, like I always like to give you 5 or 10 minutes, well, 5 minutes for this one because I'm about to do another lesson in 10 minutes, but once I finish doing my stuff and you've had a little time to try it on your own, I'll kind of turn around and then that's when I'll see if anybody needs help. So with that in mind, does anybody need help? We have questions? Really? Yeah. So where's your note? What's the concept you know? Main, I said this is the main concept. Every single thing that we're about to do. What's the concept? I said everything stems from
Little plus little.
little plus little is big. So you write that down, like just write that down until you get used to it, right? Little plus little is big. No, I mean for every problem, every time you do a problem, right? Little plus little equals big. And then just plug in what you know. What's the first little one? What's the second, like, what's the information? What's the given information for the first little one? Is it a 4? Is it a 3x? Is it a 10x? 2x subtract 7? So plug that stuff in and you should have an equation. Then, well, if you need help on the math. But now plug in. I want to see you for now write it. Once you ask me to help, I'm gonna make you write everything. So if you're doing number 1, plug in what the first little one is. If there's nothing there, it'd be like a variable. We could say x or something. Plug in what the second little one is, and then plug in what the big one is. Then you solve, and you have to do the output. Not solve or. I don't grade classwork, so if you're like these first 8 or whatever they are, these are dumb. Like these are ridiculously easy. I don't care if you do them or not. Do 1 or 2, and if you get to the point where you're like, this is dumb, go to the next section, go to the hard one. You never have to sit there and do every problem. I will never grade class. Now, if I come over to you and you don't know what you're doing and you're down on number 31, and you clearly probably couldn't even do the first 5 or 6, I'm gonna make you go back and start over. So it's up to you. Like, if you're getting it, you're not doing this for a grade. You're doing it to prepare yourself for a quiz. As I start to learn who's kind of getting stuff, I'll start to volunteer some of you to share answers. So like if I see one person's gone through the first 20 or something already and another person's on number 4, I might say, hey, when you get done with a problem, you can check your answer with so-and-so. That way you guys don't have to wait on me every single time you have answer one, check your answer. Okay, so, oh yeah, I forgot, on 10 through 23, they don't draw the picture for you. So now I will tell you, the district probably has problems like that where you've got to create the drawing. I'm going to just create the drawing for you on those though. So everybody really quickly look at, this is not the lesson I'm going to do. So really quickly look at 10 through 23. It says find the value of the variable and YZ. So you have to find both. You're gonna have to solve for the variable, then figure out what's the length of YZ. But it tells you the key part is if Y is between X and Z. So again, I'm looking at where it says example 3 and that bold. And I didn't specifically do the example, so we can, although I think in the example, it actually has the line segment. I don't know why they didn't create it here. So we're just creating this line. Oh, shoot. Actually, hold on a second. I got to get to the other. Here we go. And this is why I leave the recorder running, because sometimes there's a question, something I didn't clarify. Oh, freeze it. So they're saying if Y is between, so you're just literally following what they do between X and Z. So that's what your line segment looks like. So instead of it being like mine that was ACB, this line segment is just like that. So again, same concept, nothing different. Now they're giving you the information in the other format that I showed you. So I want you to do number 10, but I'm gonna skip all the way down and go to one of the hardest ones, which is probably like 19 is one of the hardest ones. The concept is still little plus little is big. So I'm gonna wind up, I'm gonna steal some, I don't remember who did this, but I like the way they did the shortcut version instead of writing the word out. So I'm gonna say, all right, my first little is XY. So what is in XY? Well, I'm doing number 19, by the way, so don't freak out when I don't write the information for number 10. So the XY is 3K subtract 2. And the way it's in the book, it looks like this. If you look at number 19, like that. So I like writing it in the figure. I'm very visual, so I like writing it in the figure. So then I'm going to do that for the other two pieces of information. It says YZ is 7x. What did it say? 7x plus 4. Oh, actually, these are K's. I should be writing K's. I wrote it up there, but not here. 3K subtract 2. So 7K plus 4. And then XZ, the big line segment, is 4K plus 38. So that's my drawing that it would look like. You don't have to draw it out. It's always going to be, this is all, XY is always going to be the little, YZ is always going to be the big. Same drawing for every figure. You just have to change the information. So now little plus little is big. So I'm going to create my equation. My first little, 3K subtract 2. Okay. My second little is 7K plus 4. My big, so all of that equals my big, is 4K plus 38. So that's the geometry. That gets you a C, even if you have no idea how to do the algebra behind that, which is way more complex than the example. I don't remember how hard I make the algebra on the quiz that you take. I do believe there might be one, though, that has variables on both sides. So you need to know how to do algebra with variables on both sides. I'll give you a quick version of it. You have to combine like terms on one side. So you'd have to combine those like terms. You'd have to combine these like terms. So that's the first step. Well, it's the first step I do. There's actually multiple first steps. Once you do all of that, and you'll just have one term that has a K in it, and then just one number, you have to get all the variables to one side. And the way you do that is you get rid of them on one side. I would probably get rid of them on the right. So I would wind up saying subtract 4K. Because if I get rid of the 4K over there, if I subtract 4K over here, what do I have to do? What's true about an equation? Yeah, an equation has to stay balanced. So it's like a scale. If I want to keep that scale balanced and I take weight off one side, I got to take weight off the other side. So if I subtract 4K, so that's kind of my divider line. If I subtract 4K on the right, I've got to subtract 4K on the left. And I'll do the math on some on Thursday when you have a little more practice time. We're still going to do a new lesson on Thursday, but you'll also have some practice time on Thursday. But for now, do your best on the algebra, and if you can't figure it out, just make sure you get the equations, and then we can work a little bit on algebra. in like a minute or two, I'm gonna show you the last piece of the lesson so that you can do 20, 28 through 33. There's only one little quick thing I gotta show you. Actually, kill it. I'll just do it now. Let's just do it now. Is anybody writing that still? All right, I'll keep it up for a second. If you want to write those steps that I told you and go ahead and combine them real quick. And then, like I said, once you combine these, I'll just tell you it would be 10K plus 2 on the left. And then you would subtract the 4K from the right. And then if you subtract it from the right, you got to subtract it from the left. So what would that be? 6K plus 2 on the left equals 38 on the right. Then it's just a two-step equation. You should be able to. If not, you'll see it on Thursday. Can't do that one. But yeah, if you can't do a two-step equation, you need to practice your algebra. Because almost every lesson is going to involve both geometry and then algebra. Paperclip? I don't know that anybody's ever asked for a paperclip. Curious. You don't want staples? Like the first person has ever preferred a paperclip over staples. Wonderful. Done copying. Anybody else still copying the rest of that? People sneaking their phones thinking I'm not seeing it. Again, I'm results oriented. You do well on quizzes, all good. If you don't, things change fast. All right, so do I need any of this still? Oh, I need that top part, I guess. Yeah, let's just go backwards. I mean, that's way. Actually, I can still leave that. All right, that'll work. So let's say I have this, make one quick adjustment. So I have this drawn. Well, first of all, just see if anybody knows what it means. What's that mean? Nope. And when I say what does that mean, I'm referring to these little guys. What do those mean? What do you mean by half?
Half of the segment, I mean, half of what it would be between the two letters.
So try to explain it a different way. I think you understand it and you'd be able to solve it, but I don't see if for everybody else we can give them a better, more clear version. If what you're saying is true, what is true about that figure? Use the letters that are. You don't get it, nobody. Again, I think you
I
understand.
probably don't.
You do.
What's between X and Y and Y? Like,
So now let's get a little more specific. What's true about X and Y and Z? No, that's not a line.
is that a line segment?
Nope, it's not a line segment. No, I thought you guys would have seen this. Maybe you haven't seen it before because it is definitely a geometry thing, but I mean, you've had some geometry in other classes before. That's called a congruence mark. And you may not have heard it named that, but that's what it's called. Sometimes I just call it a tick mark, but it's truly called a congruence mark. What it means is this. That's what it means. The length of XY equals the length of YZ. So the way that you use that would be if I give you information in those two, I don't need to know what the whole line segment is. So like I said, little plus little is big, right? That's what I said everything revolves around. But what if they do this? And that's all they give you. We can't do little plus little is big. I don't have, they didn't tell me what the big is, right?
My teachers is stop function.
What do you mean solve? There's no, I don't know what that equals. I mean, solve. How? What does this equal? What is 3 plus, or 3x plus 12 equal?
Yes.
But we need to know what it equals. Like, to solve it, you need a full equation, right?
Get X by itself is three.
You tell me how to do that then, can you?
Oh, okay, we have to.
What's the equation? You gotta start with an equation. Like, you can't get x by itself unless you have an equation. So you need an equal sign and something on both sides of that equal sign.
Um,
Like 3x equal, or 3x plus 12 equals 27. Like, we need that. We don't have a 27. We don't know the length of xz. Like, I don't know what xz is to plug. Oh, I erased the big. I don't know what xz is to plug anything in over here to make an equation. Why don't you know who did? Oh, you answered a lot. So re-answer. I should have called on. Were you raising your hand? All right, I'm gonna go to the. Oh, you can't just add, because here's what you would get. If I just did little plus little, and then plus 2x plus 18, can I solve that? Like, I don't have an equals. Now I could write this and it's technically correct, but I can't solve it. That equals xz. Now that's a correct equation, and I'll actually give you some credit for that because that's little plus little is big, but I can't solve that. Xz is basically like having a second variable. I can't solve an equation that has two variables. So there we go. I told you these congruence marks means that those line segments are equal, you know? I had it right there, sitting there. Yeah, I was hoping somebody would see that. So yeah, if I know that they have the same measure, if I know that that is the equation in this situation, that the two segments equal each other. So you just say, okay, well, what's in xy? Well, that's 3x plus 12. What's in yz? 2x plus 18. That's the equation in that situation. Sometimes they'll still maybe give you the big and you still add them together, like they might have done this. They might not have given you that. And they might have done this. 10x minus 4. Subtract 4. I hate saying minus. They might have given you that. So again, if I did little plus little, 3x plus 12, but then what do I write for the yz? I don't have anything. Well, but I need the other little. What's the other little? I gotta have little plus little is big.
I need to do 3x.
Hold on. I gotta point something out. I'm feeling so excited, I think right now. She knows, and I think you're saying the right answer because I heard what you started to say. And I believe you're right. But it was funny. I could just tell when the way you shot your hand up that you knew what the answer was.
It's just
How
simple
funny.
algebra.
Well, but we don't have an equation. So here, so I gotta tell you this right now. You gotta be focused on creating an equation first. So I can't solve anything yet. I don't have enough information in the picture to solve, to even create an equation. You have to create an equation first. So always focus on what is my equation. So again, with that in mind, what's my equation? And this is it. This is, in this case, this is the correct equation. We can't set them equal because we don't know what this is. I can't set this equal to this because I don't have anything there. So what we can fill in the first little. What's the first little? Yeah, 3x plus 12. We know that. We got that. It's in there. Plus. Well, let's do the big. Let's just go ahead for everybody. And again, I think you know where we're going, but so what do I put over here? Like big. Yeah, the big is the 10x subtract 4. So I got that, but I've got a gap. That's like having, again, a second variable. I can't solve something with two variables. Somehow I got to fill that in without putting a brand new variable in that spot. What would go there? I gotta do some calling on for names, for instance. Forgotten some names. My goal is to have them all. Can't just put X there. We don't know that it equals X. Because X is already used, like X is some number, and I can't just say, oh, well, yeah, that's that same number. Because I know it's actually not that. Sure, I guarantee you it's not. What do those marks mean?
That's right.
So let somebody now connect the dots. Those marks mean those two smaller line segments are congruent. They're equal. They have the same measure. Somebody said it. So say what? Yes. You write the same thing. If this is the same measure as that, then it's 3x plus 12. Which means this is 3x plus 12. So that's another way you'll see those congruence marks. Typically, whenever you see congruence mark, well, not typically, but for this lesson, it means they're not going to give you as much data as you're used to getting, which means there's some, you got to figure out how to fill in more data using those marks. All right, so now you can do 28 through 33. I've got everything assigned. That is, holy cow. Oh, you're in school though, right? I don't know what I'm supposed to do if you get to school this late. I don't even. I think I'll mark you out. All right.
I just woke up.
Oh, okay. I was thinking maybe things weren't okay. So that's it. Now I'm gonna stop the recording. So the lesson is recorded. So you'll have to go back and watch the whole thing. You can do it while you're playing dominoes. Yeah. That's what you can. Yeah, I'm sure. Stop recording. Yeah, but it'll be on my. Oh shoot! I forgot to show you that. I meant to show you that on the recording. Oh well. I will